Hello students, welcome to the topic definite integration. We will continue sum based on definite integral as the limit of a sum. The first question is, that is, integration of e raised to x with respect to x goes from a to b. Students, this problem we have to solve it as definite integral as the limit of a sum, not your fundamental principle. So, the steps will be this way. Let us consider the given integral as I. Integration goes from a to b e raised to x with respect to dx. So in this case, the function is e raised to x, correct? And the lower limit and the upper limit remains a and b. So integration of f of x with respect to dx, that can be expressed as a limit of a sum, that is limit as n tends to infinity summation of f of a plus rh into h. R goes from 1 to n. So let us apply that formula. So I am taking that formula, limit as n tends to infinity, summation r goes from 1 to n f of a plus rh into h. What is the value of h? That is equal to b minus a upon n, right? Now here a plus rh will becomes, that is function f of a plus rh, right? And therefore it will be e raised to a plus rh into h, right? Now let's see the next step. We are applying for definite integral limit of a sum, and in this problem the function is e raised to x, which we have written as f of x is equal to f of a plus rh, that is e raised to a plus rh, which further we can write it limit as n tends to infinity summation r goes from 1 to n e raised to a plus rh, that is e raised to a into e raised to rh into h. Now to solve it further, first take out the constant term outside of your summation sign. So limit as n tends to infinity, e raised to a into h will be outside. Summation r goes from 1 to n e raised to rh. Now e raised to a into e raised into h will remain as it is. Now for the summation of e raised to rh as r goes from 1 to n, here it becomes as a gp, that is summation of e raised to rh. And for that we have the formula for Sn. What is that? A bracket r raised to n minus 1 upon r minus 1, provided r is greater than 1. So let us apply that formula. So limit as n tends to infinity, e raised to a into h will be as it is. Now in bracket, by applying the formula, look at that. The first term here, a value is e raised to h, right? Then r raised to n, here the ratio is e raised to h into n, so it becomes e raised to nh minus 1 upon e raised to h minus 1, right? Now let us solve it further. The first term, that is e raised to a into h will be as it is, right? But now I am writing first e raised to nh minus 1, this bracket, as a first term. Now I am dividing the numerator and denominator by h. So because of that, in numerator we have h, that will get cancelled. And in denominator we'll get e raised to h minus 1 upon h. So see the step. The next term will be e raised to h upon e raised to h minus 1 upon h, right? Now let us solve it further. Here, since the value of h is b minus a upon n, I am substituting that. So limit as n tends to infinity, e raised to a inside the bracket e raised to n bracket b minus a upon n minus 1, and the second bracket will be as it is, right? Now here in the power, that n and n will get cancelled. So the next step, n tends to infinity, here e raised to a bracket e raised to b minus a minus 1, right? Here we are applying the limit to the second bracket, that is e raised to h upon e raised to h minus 1 upon h, limit as n tends to infinity. Now look at that. First term will be as it is, e raised to a bracket e raised to b minus a minus 1. As limit n tends to infinity, here h tends to 0. So we'll write limit as h tends to 0, applying the limit to the numerator and denominator. So limit applied to e raised to h as well as e raised to h minus 1 upon h. And here I am writing the reason, since n tends to infinity, h tends to 0. Now look at that. The first term, e raised to a and e raised to b minus a can be written as e raised to b upon e raised to a minus 1 into, here as h tends to 0, e raised to 0 becomes 1, right? Upon, that's the formula of limits. Limit as e raised to h minus 1 upon h as h tends to 0 becomes 1. And that is equal to e raised to a bracket e raised to b minus e raised to a upon e raised to a. So e raised to a will get cancelled, right? And the final answer will become e raised to b minus e raised to a, right? Now let us solve one MCQ which is based on definite integral as limit of a sum. Sum is limit as n tends to infinity 1 raised to p plus 2 raised to p plus 3 raised to p plus n raised to p upon n raised to p plus 1. And the options are given 1 upon p plus 1, then b 1 upon 1 minus p, c 1 upon p minus 1 upon 1 minus p, and d 1 upon p plus 2. And the answer is option A, 1 upon p plus 1. Let's see the solution. Here, limit as n tends to infinity 1 raised to p plus 2 raised to p plus 3 raised to p plus up to n raised to p upon n raised to p plus 1, which we can write it as n raised to p into n. This n we can write it outside. Now in numerator, all the terms having the power p, as well as in the denominator it is n raised to p, right? So we can write it this way. Limit as n tends to infinity 1 upon n. Here we are splitting the terms and we can write 1 raised to p upon n raised to p plus 2 raised to p upon n raised to p plus up to n raised to p upon n raised to p. So which we can write it this way. That is limit as n tends to infinity 1 upon n. It is a summation. Summation r goes from 1 to n, r upon n whole bracket raised to p. And we know that summation of r upon n can be written as integration of f of x, right? Goes from 0 to 1. So similarly here also we can write integration goes from 0 to 1 x raised to p with respect to dx. And we know the integration of x raised to p, that is x raised to p plus 1 upon p plus 1, goes from 0 to 1. Let us apply the upper limit and lower limit. So 1 upon p plus 1 will be outside. 1 raised to anything is 1. So the final answer becomes 1 upon p plus 1, right? Thank you.